Hi, and welcome to the screen class on interactivity and graphics in Raptor. This is part 2 of a 2-video series. This is for the Computers and Technology 11 classroom. Alright, so in this part 2 we're going to cover what we didn't get to due to the length of the video in the last one. This will be trying to understand draw calls and draw orders, not a difficult concept, and explore the mouse interactivity get mouse button function inside of Raptor. Try to understand the X and Y coordinate system in that respect, and check out how to detect click position and run logic off of that. Okay? Alright, so just like the first video, it's going to be back and forth between the presentation and Raptor, and although, and Photoshop too, of course. Alright, so let's look at some mouse interaction. Well, no, let's not do that. Let's go ahead and look at stacking. Okay, so the concept of stacking is very similar to that of layers inside of Photoshop. Inside of Photoshop, if, let's say for example, we want to have a background, well, we apply our background and we have to look at the order of these layers. Now, let's say for example, I want to have this rectangle show up, but if I try to put my background after I've already put the rectangle down and it's on a higher layer, it will cover it up. So if I want these rectangles to appear on top of the background must be drawn first. So it's on the lower layer. Then every rectangle and subsequent rectangle can be drawn on top of the background, as long as the as long as their size is not the same as the background will appear underneath. Okay, not a difficult concept to understand. Inside Raptor, it's the same. Alright, so this program that I've made is very simple. I have one class, and this class has a constructor and 4 functions. The 4 functions take no parameters. Alright, we have draw cat, draw fish, draw dog, and draw background. We can look inside of these methods. Draw cat loads images from this. We can go ahead and delete these backups. Don't need those. Alright, so I have some images here. I have a cat image. So that's the image that will be drawn for the cat. I have a fish image, this one. A dog image, this one. And the background. Now all of the measurements are the same for everything except for the background. The background will take up the entire width and height of the graph window. Inside of main, the only thing I do is I make an instance of this class called myPainter, and it's a new painter. That's the name of the class. And I open my graph window. So if I play this, right now, the only thing that happens is the graph window opens, width 800, height 400. Alright, so let's go and make some calls to these functions. So inside of main, I'm going to tell the myPainter that I want to draw the dog. Alright, so I can run that and I see that the dog has been drawn. Now, since the cat is in the same position And to prove that, I'll go ahead and just change this to draw cat. And you'll see it's in the same position as the dog was. So if I do both of these, what happens is the last one that gets drawn is the one that will appear, even though they both get drawn. Okay, let's go through it step mode. So first we make an instance, goes through the constructor. The graph window is open. We call the method drawCat, so that loads the cat JPEG into memory as the bitmap variable. And then we say draw bitmap, which was that variable. We're going to draw it at 200 in the X, 400 in the Y. The size is 200 by 200, and there we go. It gets drawn. Now after that, draw dog gets loaded and then drawn to the canvas or to the graph window. So the last one that gets called, or the last one that gets drawn, will appear on top of the other ones. Okay, so if you have something like a background image, you have to do that first. Alright, so if we want to actually run this, we want the background image to appear behind the dog. We have to draw the background first, so it's the bottom layer. Okay, the bottom layers get drawn first. If we do it the opposite way, then you can predict what's going to happen. The dog will get drawn, but then the background will get drawn on top of it. Okay. Alright, so let's say, for instance, we want to change some of these around. Let's say we want to actually have all three or all four images actually on top on this. Okay, so we have our width. What is our width again? 800, I think. Yeah, so it's 800. Okay, so if we're going to draw all of these and have them all fit on this, so let's see, let's do a little bit of math. Let's go ahead and do draw cat first. We'll do that at the first position. Alright, for right now, let's just concentrate on the width. So if you remember from the previous video, we're going to, let's see, draw this at 100 in the X. That's actually not correct. It's going to be 50. Why 50? Well, you'll see when I'm finished. And I'll change this part to 300. Not entirely sure that's going to be what I want, but let's see. And we'll leave it at 200, 200. Alright, so let's do a draw cat. Alright, so that's exactly what I wanted. I want equal space here, equal space here. Alright, so why 50? Well, each of these is going to be 200 in width. So 3 pictures, so it's 200 times 3, that'll be 600. And that's going to leave 4 blank spaces. 1 for this edge, 1 for this edge, 1 for the space between these 2 pictures, and 1 for the space between these 2 pictures. So we take what's left, which was 200, so 200, 400, 600. So, okay, 600 or 800 minus 600 is 200. Take 200 and divide it by 4 because we have 4 blank spaces, and we end up with 50. So we need to have 50 between each of these, and each of them need to be 200. Okay, and we'll draw them all at a different place. So draw cat first, and we'll go ahead and just copy this one. Go to draw fish, get rid of that, paste. The only one we need to change here, we're only going to the next image, we're going to move it further into the X. Okay, we're not going to move it in the Y, it's going to be in the same position. Now, what do we need to put it at? We need to put it at 300, right? 50 plus 200 plus 50. Okay. Then we go to the draw dog, delete this, put this back in here. So 300, so the next one will be, so 300 plus 200, that's 500, plus 50. Okay. Now we'll go ahead and make 3 calls. We'll do them in order. Do dog, draw dog. I think that's right. No, fish was next, actually. It doesn't matter for these, since they're going to be drawn in different positions. It doesn't really matter for these ones. But just for consistency's sake, let's keep them in the correct order. And I messed it up. So what did I mess up? Well, I messed up the Y. I must have changed the Y instead of... Yep, that's what I did. Okay, so the Y is supposed to be 300. This is supposed to be 550. There we go. So now we have an equal distribution, and let's say we want to add a background image. We can go in and say we want to draw a background. There we go. Alright, so let's say we have these 3 images, and we want to detect a mouse click. Alright, so let's go into the Raptor help and check out what kind of methods we can use for that. Just do a search for mouse. Alright, let's see the ones we have. We have get mouse button, get mouse X, get mouse Y, get mouse button down, mouse button pressed, mouse button released, wait for mouse button, etc., etc. And you can click these and see what they do. Don't be afraid to use the help. This is an excellent resource. Alright, so it says wait for mouse button is a call that delays the program until the specified mouse button has been clicked. Wait for mouse button does not provide the location of the click. To wait for a mouse button and know where it was clicked, use the get mouse button, this function. Note that if the program is waiting for a left click and the right mouse button is clicked, the right click will be lost. Alright, so this is the one we're going to use, get mouse button. So let's go there. Get mouse button has 3 parameters. Or, yeah, 3. The first one is which button you're going to click. The next one is a variable that is actually a return. The next one is another variable that is a return. Alright, so what do I mean by that? Well, let's take a look. Alright, so here's our function. Okay, the static var button or mouse button. Then we have an integer x and an integer y. Okay, let's take a look at what this means. This is done as a call. It's a method call. Okay, this function is different than any we've used before because we have a static, that's something that never changes, and there's only ever one of them. There's only one left mouse button. Okay, and we also have 2 return variables. Okay, the x and y. So this parameter and this parameter are returns. So what this means is that when this function is called, this variable x and this variable y will be automatically created, and that they can be read to get, whenever the mouse button was clicked, the x position of where it was clicked and the y position of where it was clicked. Okay, Alright, so let's take a look. Actually, let's go and look at the final slide. Okay, these local variables can be compared to other values for logic operations depending on the mouse position when the button defined as button is clicked. Okay, this function call will pause the program until the given button is clicked. So whenever you have this as a call, it will freeze the program at this position until the button that you define here is clicked. Once you click that button, it will then return two variables, x and y, back to wherever this is called from. So if you do it inside of main, these two variables will now exist inside of main. They will both have an integer value. The x will hold the x position of where the mouse was clicked inside of the graph window. The y will have the y coordinate of where the mouse was clicked. Alright, so let's go ahead and take a look at some of this functionality. Close this down. So let's say that after I draw these pictures, I'm going to make a call to get mouse button. Okay, which mouse button do I want to get? I want to get my left button, and I'll just say X, Y. Okay, now X and Y will exist, so let's go ahead and play. It's paused right here. If I click, you'll see that, okay, my program's over with because that was the last symbol, but it returned X192, Y242. Okay, now I can use these variables any way I want to. I can use, for example, right inside of here, I'll return X and I'll return Y, or output, sorry, not. Alright, then let's say I click here. Now, I clicked at 50, 300. Now, the numbers should seem pretty familiar because that's exactly where I told this to actually draw this image. I said at 50 in X and 300 in Y. So 50 over, 300 up. Okay? Now, I can go and use this information now, the X and Y, to do some, some checks. And what do I mean? Well, let's see what I mean. So, let's do a selection. And let's check and see if I've clicked the cat image. Alright, so just do a little bit of math here. If the cat image, the X starts where? Starts at 50. So the width of the image is 200 and it starts to be drawn at 50. So if X is between 50 and 250, then I've clicked somewhere in this area. Could be up here, could be down here, but it's not any of this area, and it's not any of this area or over here. So if X is between 50 to 50, I've clicked in between this column. Alright, so let's say if X is greater than or equal to 50 and, and X is less than or equal to 250, I'm going to return, and I'll say, for example, clicked near the cat. Otherwise, didn't get close to the cat. Alright, let's go ahead and hit play and see what we end up with here. So if I click the dog, I didn't get close to the cat. If I click the fish, didn't get close to the cat. If I click over here, clicked near the cat because I clicked in the column that's from X50 to X250. Okay. Now, so if X is greater than or equal to 50 and X is less than or equal to 250, if that represents clicking anywhere in this area, we can also check to see, well, where is Y? If Y is between, so what's this one? 300 and 100. All right, because remember, we drew it at 300. We started it here at 300. It's 200 in height. So 300 minus the 200 will give us 100. All right, so 100 is here, 300 is here. So if Y is greater than or equal to 100, but is less than or equal to 300, then we're clicking somewhere in this area. We're not clicking up here, we're not clicking down here. We're clicking in this row. Okay? So what we can do is we can do a check for all of these things. If they're all true, that means we clicked on the cat button. So if X is greater than or equal to 50 and X is less than or equal to 250 and Y is greater than or equal to 100 and Y is less than or equal to 300, I've clicked the cat. If these are not true, or if any of them are not true, I didn't click the cat. All right, let's give it a try. If I click the fish, didn't click the cat. If I click above the cat, didn't click the cat. If I click the cat, I clicked the cat. All right, let's go ahead and try to get the rest of them. All right, so let's go ahead and copy this entire thing and paste it over here. So to pick up the fish, what do we got? So if X is greater than or equal to, think about it for a second, and what is this position? Well, the Y position is not going to change. It's still going to be in the same column. So the only thing, or sorry, the same row, because this one is drawn here. Well, the Y position, and just in this direction, for all of these is exactly the same. The only thing that changes is their position on the x-axis, so how far to the right that we move. Okay, so these two are the only ones we're going to need to check. And actually, I would make the y variables here to be statics, but we don't really need to do that at this point. And I could even make them into functions that would return a Boolean, but we haven't gotten to that stuff, so we'll just stick with the basics. What I'm trying to say is this code is not really that complicated. It really isn't, but it's more complicated than it really could be. You can make it even easier than this. All right, so, but this type of things are what you've seen in math class and also what we've seen in this class. So we'll just keep it with what we've already seen. All right, so let's go. I want to do a little bit of cleanup here. All right, so our x value, so we have 50 plus 200, 250, plus 50 is 300. So the x is going to be between 300 and 500. All right, so if x is greater than or equal to 300 and x is less than or equal to 500, that means we click the fish. Okay. If these are not true, we can go down the cascade again, and let's pick up for the dog. Alright, same thing. Dog is 200 in width. So we have 200, 400, 500, 550. So he gets drawn at 550, and he ends at 750. Now, this is for my window that's 800 in width. Obviously, if you make a larger screen, which if you make any kind of game or application, you probably should make it a little bit different, okay? As far as the width and the height, okay? So, I obviously did not click the cat in this case, but I clicked the dog. Alright, so with this bit of code in place, I can do some logic here and say, okay, I click the dog. Here, nothing gets called because nothing, okay? Let's go ahead and make a catch-all and say, you didn't click anything. Right? Hit play again, click here, didn't click anything. Click here, didn't click anything. Click here, click the cat. Click here, click the fish. And the dog we already ran before. Okay? Go ahead and switch the size here a little bit so we can see more of this. Okay? Alright, so what else? That was about it, I think. Yeah, click position detection, understanding the X and Y coordinate system here. The get mouse button function pretty much covers it. Now keep in mind here that you don't have to do just these little outputs. Alright? Let's say, for example, that we want to I don't know, we want to actually maybe make some kind of image appear on which one that we click. You could easily do that. Let's go ahead and do something like that. We'll just use the background image again, and we'll draw it on top of the image that we click. Okay. So let's see. We'll make a new method, and we'll call this method overdraw. Alright. And we will, there's easier ways to do this. I wish I would have, I could go back and rethink that, but alright, so we'll see, we have an int x and int y. Alright, so it's going to accept two parameters. These parameters are going to be wherever we want to actually draw it. Okay, so inside of main, let's say if we click the cat, we will call the overdraw. So for example, my painter, and we'll call the overdraw, and the values that we'll enter we'll just get from the position of the cat here. So let's see, x is 250, so let's just do it at, I don't know, 175 for the x, and the y will do 200. And these are just random numbers, they don't mean anything. They're random numbers that I chose between here. If it's greater than or equal to 250 and it's less than or equal to 250, I just grabbed 175, okay? Alright, done. And over here I can do something similar. for the fish, okay, we'll do the my painter, and we'll draw, overdraw, and let's see, 300 to 500, so we'll do 400, and we'll do, let's see, what, a Y is, okay, we'll just do the same thing, 200. Obviously the Y is not going to change. And here we'll do the same thing. My painter, overdraw, and Y is going to be 200. X is going to be, let's see, 550, 750. Let's just do 625, I guess. 625. Okay. So it's going to draw something at this coordinate. Well, my painter, or overdraw, currently doesn't have anything. Alright, so let's grab this information from the background, put it over here in overdraw, and let's make this size a little bit bigger. So we're going to load the background image, obviously. We're going to draw the bitmap, and where are we going to draw it? Well, we're not going to use this 0 and 400 static coordinates. We're going to use these variables, or these parameters, that are passed into this method, whatever it's called. Alright, the size we're also going to change. I'll just make it 50 by 50. Okay, so let's play. Click on the fish, get this image over top of it. It could be a thumbs up or something like that, or a check mark, or whatever you want to do. Test the dog, same thing, an image appears, and then the cat. Obviously the measurement's off, but I wasn't really trying to get it centered. I was just trying to get it to function. Okay, obviously for our catch-all, maybe we want to do something as well. For example, close the graph window. So just in case I don't click in at the right place, I get you didn't click anything, and the graph window gets closed. Okay. Alright, so that pretty much covers what I wanted to cover here. The idea here is to actually be able to display something for user interaction, not just having text inputs and things like that all the time. Some of this functionality will definitely be expected. It will be some of the requirements for the personal project. I think I mentioned actually using a draw or an array to actually do some of this, so we'll go over that as well. Now, if you looked at my folder, I actually have some that were just labeled 1, 2, and 3. Now, the reason I have these named 1, 2, and 3 is because I could maybe use an array and a loop to draw these images. Okay, so I'll just leave the class alone, leave it there, that's fine. And let's say, how do I want to do this? I guess just delete everything. It's about the only way to do it. Alright, so let's make a loop. And this loop I will Alright, I'll make an iterator here at the top. Count. I can't think of anything useful to do with this right now, not with the way I already have this set up. So maybe no, I can't really think of anything to do with it without making the video a lot longer. Well, let me undo and get my measurements back. I'll start here. I'm just going to make a loop here. I'll make my iterator here. Set it to count equals 0. I'll make an iteration here. Count equals count plus 1. Alright, the comparison I'm going to do is, well, first of all, I will make I'll just make a simple array. I'll call it pictures, and I'll set it equal to whatever count is. And how will I access it? Well, we're going to set it equal to pretty sure I can just put a bitmap inside of there. So I'll say count plus, actually, load bitmap, count plus string dot jpg. Okay. Got to make sure I put the count part. What left parentheses? Ah, okay. There we go. That was stupid. All right. So if you look at the logic here, first time it comes through here, actually, I didn't do that, okay? All right, so first time it comes through here, count gets set to 1. So pictures 1 will be set to, remember that this is a variable, right? Inside of this array, these indexes are variables. Variables are what hold the return from the load bitmap function. So we'll load bitmap, whatever count is. So this is a variable, so it'll be, for example, 1. Then we'll append the .jpg string to it. So it'll be 1.jpg. Just so happens that that's the name of this file. We go into it and say properties. It's called 1.jpg. Okay. And all this stuff with the mouse click, I'm not going to do it here. All right. All this stuff, I'm not going to do that either, or that, or that. All right, so the only thing I want to do here is to actually go through this iterative process and draw this image, all of these images, okay? Now, what I actually need to do here is I need to make this, well, inside of the loop, the exit condition for this is going to be if count is not equal to what's it, pictures, sorry, length of pictures. But the problem here is when I get this far, it's going to say, well, there's no such thing as pictures, because pictures isn't created until inside of the loop. See? So what I actually want to do here is I need to make this array before I use the array. And that's simple enough. the only thing I need to really do is just make it first. Okay, I'll set pictures 1 equal to, actually, you know what? I can't do that. I don't know what I was thinking there, actually. This would have to be 2 different loops to do it that way. So instead, what I can do is draw how many pictures, and I'll set this to number choice. Alright, and I'll just compare count. If it's not equal to number choice, then that's the way it will go with it. Okay. Alright, so if count is not equal to num choice, we keep doing the iterative process. If it is, then we exit. Okay. So what we can do here, we go through here, we load these images into pictures. Okay. Now for the next loop, we'll take the same array and we'll draw it. Okay, the loop condition here, we can actually use this length of function to look at the length of this array that we've created. So first thing we do is we reset our iterator. No point in wasting memory by making another one. Alright, so if, here we go, the count is not equal to length of pictures, then we keep running. Okay, so inside of here, what we'll do, we already have these loaded into memory, and the graph window will be open. We don't really need to make a painter anymore. So what we'll do is we'll iterate through this array and draw each one of these. Okay, so we'll make a call here. And we'll say draw bitmap. The bitmap that we're going to draw is pictures count. Okay. The X, it doesn't really matter. Say X. Let's say that I actually want to move this over each time. We can do that. Let's say for the first time I want to move, I'm not going to sit here and do the math, but let's just say I take count times, let's see, and I sit here and said I wasn't going to do the math, and yet here I am. I'm just going to kind of wing it though. Let's just do count, which will be 1 the first time, times 100. Let's just do that. So the X position will be count times 100. The Y position, let's say that it's going to be, I don't know, let's just make it 300. The size, we could say, I don't know, let's do, for the first one, well, let's just do 100, now let's just do 200 times 200 again. Okay, so each time it goes through here, it's going to move over to the right depending on what count is. Alright, so let's run this. How many pictures? Let's make 3, and there we go. You can see here that they each get moved over just a bit for each time it goes through. So we took count and actually used count to determine how far to move over. Now we can take this and change it to 150 and see what we get there. A little bit further. And so it looks like probably 250 is the magic number. No, that's it's not the magic number. Oh, it actually is. It's just the first number is too much. So 250 actually is the magic number. But the initial x is too much. No, that's not going to work. Alright, well, we could say, for example, do this first, and let's then divide it by 2. Nah, that just messes it up. Alright, well, you get the general idea. I'm not going to plug around with math, and I'm not going to pull out a calculator either. You get the general idea of what I'm trying to do here and how we can use an array to systematically build the pictures that we want to draw in order using count and using a little bit of math on the count variable. Okay? You just got to make sure if you do it this way that you have the images named the correct way. You know, 1, 2, 3, whatever. Now, you don't have to do it that way. You could go in here, for example, and say, well, do a selection, and, you know, if count is equal to 1, draw, you know, cat. If count is equal to 2, you know, etc., etc. But then you would actually have to compensate for each and every image name. All right. If you just have images 1, 2, 3, whatever, whatever, and do it this way, you won't have to actually do that. Okay. All right. So I've let this run on long enough. I hope you picked up some valuable information. I hope you followed along, because that's how you learn this stuff, is you learn by doing. Alright, so that finishes up this entire video. I know that this is pretty long, but it is what it is. Have a good night. I'll see you in class.